Hello everyone, welcome to my session. Today I'm glad to present my recent research, zero-shot recognition via optimal transport. This is a joint work with Hongteng Xu from Renmin University, Guoyin Wang from Amazon Alexa AI, Wenqi Wang from Facebook, and Lawrence Karen from Duke University. In the past few years, modern machine learning has achieved remarkable success when they have access to abundance of label data. However, its generalization to unseen classes remains poor. This motivates recent researcher interest in zero-shot learning. Basically, we are trying to leverage the auxiliary information such as tags or attributes so as to predict classes that are not even seen in the training time. However, there are two major issues. One is domain shift. The classifier learned on the seen classes cannot be easily adapted to the unseen ones. And the other is the high bias. The classifier are easily biased towards the seen class. Motivated by the fact, we have proposed an optimal transport-based framework for zero-shot learning. It is a conditional generative model to synthetic image features from the attributes. Then they are trying to minimize the optimal transport discrepancies between the generative features and the real ones. To further improve the predictive power, we introduce an attribute to the predictor. Further, an iterative optimization solutions is proposed to jointly learn the optimal transport and the generative model. For the learning objective, we include two major components. One is the optimal transport-based loss, and the other is attributes-based regularizer. The former assumes the image features for both the generative ones and the real ones are uniformly distributed. And then we define the cosine distance as the cost matrix. Then we build the optimal transport framework for the generative model. To further improve the predictive power for the model, we introduce the attribute-based regularizer. It tries to confuse the predictor for the generative features and the real ones. Combining the two components, we have proposed an iterative optimization. Typically, when we learn the optimal transport, we fix the generator, and then we fix the generator to learn the optimal transport. Given the proposed models, we have achieved state-of-the-art performance for generalized zero-shot learning on 4 benchmark datasets. Further, we demonstrate the predictive power for large-scale dataset, even for ImageNet. To further understand the generative powers, we visualize the AWA2 datasets using t-SNE, and we observe that the real image features and the generative features are closely distributed in the latent space. So in summary, we have proposed the OT zero-shot learning, which is a generative framework designed to minimize the optimal transport discrepancy. Second, our model provides a robust distribution matching solutions for zero-shot learning tasks. Thank you very much for your attention, and I'm here for questions.